Okay, so our last part for Fundamentals 1.1 is talking about like terms. There are a whole lot of definitions in this section leading up to like terms. So terms are constants or constant times some sort of mishmash of variables. But terms are a bunch of stuff being multiplied. Then when we're combining like terms, we're looking at the addition and subtraction of these multiplication mishmashes. So when we're combining these, we're counting how many of each one. So when I have 3x squareds, we can think of that as 3 copies of x squared, where x squared is a thing, a variable abstract thing, and 3 is telling us how many we have. So we're going to use that as we look through. Now, when I have 3 x squared things, and then I have minus 12 x things, x squared and x, they do have a relationship, but they are not exactly the same. So I can't talk about like adding squares and then adding lines. Squares and lines are not the same thing. They are different. Lucky thing, little line. So that is the first important thing is if you're ever asking yourself, what variable or what power do I write on the variable? Odds are you're making a mistake with your like terms. There shouldn't be a question of what the variable is because you're always looking to make sure the variable and the exponent are the same. Okay. So the first part is identifying the like terms. So identifying the guys that have the same types of things. So some people think of them as like apples, or some people will use shapes. I'm going to use colors. So our 3x squared, I'm looking for anybody else with an x squared. Minus 12x, nope. Plus 11, nope. Minus 4x squared, aha, ding, ding, ding. So I'm going to call that a like term all the way back, including that negative on the 4. Plus 3, just a regular x, minus 12. Okay, so that's our first pair of like terms. Now our next pair. The next term I have is negative 12x or minus 12x. So I'm looking for other terms that have a single x. So plus 11, no variable. Plus 3x, there it is. And then minus 12, no. In fact, those two leftover terms are just numbers. Those are called constant terms. And they can be combined. In fact, the same way we do the constants is what we're going to do on the rest. We're just going to copy whatever thing we were talking about as the label with it. So if I have 3 square things minus 4 square things, which let me go ahead and write that. So 3 square things minus 4 square things. Well, I'm trying to take away more than I have, so I should end up negative, and I've got 1 extra that's owed to me, if you will. So negative 1x squared, that can also be written as just negative x squared. They mean the same thing. But for problems like this, I prefer to write the 1. It doesn't hurt to write it, always fair game to write it. Now, minus 12x plus 3x. Those are both x's, single x's. So I got negative 12 of them, and then I'm going to add 3. So we got some canceling going on. So if I add 3, that gets me to negative 9. So negative 9x or minus 9x. Like if we were going to read it all together, we'd say negative x squared minus 9x. And then we have our last terms. That was a plus 11 minus 12. So 11 minus 12. We're trying to subtract more than we have, so it's going to end up negative, and it's just 1 negative. So negative x squared minus 9x minus 1. So multiple ways to think about like terms. The big thing is when you're combining, when we say combining like terms, we're talking about addition and subtraction, not multiplication and division. So you're adding and subtracting, collecting your like terms, totaling your like terms. And when we talk about that, It's like thinking about objects. Like I've got 3 apples minus 4 apples. Okay, I've got a negative apple. I owe someone an apple. Negative 12 oranges plus 3 oranges. All right, negative 9 oranges. I owe somebody negative 9. Owe someone 9 oranges. Okay. And then $11 minus $12. I owe someone $1. That's how we would get to one of our ways to think about the answer. But I don't go negative 12 oranges plus 3 oranges is negative 9 oranges squared. You don't change the label when you're talking about adding and subtracting these guys. When we get to multiplication, things will go a little crazier. That's when we have our exponents doing their little game. I got a cheesy joke for that, but collecting like terms, make sure you keep your labels the same.